I not even need to be here? Are you just going to solve everybody's problems?
No.
You sure?
Definitely not.
Because I'll be happy if you do. Then my work here is done. Okay. All right. So is the person who sent this file here? Oh, you are. You're in the back. Okay. With like the hood and the mask. All right. Now with just the mask, I recognize you. And once you spoke, I also knew that it was you. All right, perfect. And so this is the ESPRIT file you sent. Do we have, and you've got tools and stuff in it? Okay. I was just starting to look at it before you guys got here. So did you create stock material for this operation already? All right, so let's take a look at what you got for stock material. Is it like it's not on a different layer? So you went to the simulations toolbar and you did here in solids, you created this stock. All right, so I can see the stock if I click the play button, even though there's no operations, right? All right, so let me just go do that and just double check where the stock shows up. All right, so the stock shows up visibly where the part is. So let me just double check and look at the definition. So you made a 2.25 by 0.475. So do you have that piece of stock that you've measured? Was that thickness? But did you measure it? Do you know that it's that thickness? You do. Okay. That's because like the first thing with doing the stock material is you need to define the stock material in the CAM software with exactly the same size and shape as it actually is going to be in the machine. That lets you do the programming and it lets you see if it's going to crash when it's doing the operations, right? All right, so it's 4.475 in width and so 875 tall. Okay, and you shifted it down minus 0.875. So the top of the stock is right here at the same plane where that red plane is, right? Which means we could do a facing operation there that would maybe touch the surface, maybe not touch the surface. It depends on how well we set the work offset, how well we set the tool offset, and how level the part was in the fixture. Does that make sense? So often what I'll do is I will purposefully have the stock be a little bit taller than the workpiece. The easiest way to do that, because when we set up the machine, it's easy to probe the top surface of the stock. And so the easiest way to do that is to actually shift the workpiece down a little bit in Z in the CAM software so that the stock is aligned with the top. And we're shifted down in Z a little bit. The other thing is this plane right here. That's going to be lined up with that edge of the stock material also, right? So if we shift the workpiece down and right a little bit, is the stock material wider than the workpiece? What's the dimension from here to here? Do you know? All right, so if we don't know what that dimension is, we can actually pretty easily get it. The thing I'm going to do first is I'll quickly turn off sub-elements. And I've got highlight turned on. And now if I click this, it selects the whole part. Once I've got the part selected, I'm going to right click and say copy. And I'm going to, so copy in ESPRIT doesn't just copy, it does a lot of different things. And what I want to use is this smash command, which lets me make a wireframe on the outside edges of the part. So it creates geometry features on the part. And so if I do that, now if I have highlight selected, I can click here and it says, hey, is that the feature you wanted to select? And it's calling this line S1. And so I say, if I left click, I say, yeah, that's the feature I want. If I didn't want that feature, if I click here, it says, hey, did you want S1? If I right click, it gives me the next option that it found, which is the solid. And since I don't want the solid, I'm going to right click again, and then it goes just right click until everything goes away there. And then I'm going to go here to that S1. And so when I have it selected, I can, if I've got the properties window open here, and you get that by going view properties. So if I've got properties open, when I select that line, when I select the line, I can see the length is 4750. So it's exactly the same width as the stock material. There's nothing I can do with the position of the part front to back in this view. But I can move it down and I can move it to the right. So we're going to machine on both edges of it, I think. How long is your part? Okay. So the other thing we can do here is we could measure, or we can, so we know that this line right here is on the 0, right? It's lined up with the z-axis. So we select this line right here. We can see what the x coordinate is. So x, y, z of either the start or the end point, right? So it's 2.25. I don't remember what your stock definition was. So let's go back to that. So your stock is 2.25, 4.75, 875 tall. Cancel. That length is 875. So the part just barely fits in the stock material. So I guess we don't have to move anything because it just barely fits. And if that's the case, then the only feature that we can make from this orientation with an end mill is this little shelf over here, right? So we want to make the, if I turn on sub elements here, we want to make that surface, right? From this orientation. And we want to make that surface from this orientation. Because the tool could make a pass across there and do that. And so to do that, we really just need a contour path. Go back to my isometric because it's easier to view for me. And so what I really want is a chain that goes from this corner over here to this corner over here. I can do that by going to the features, so the create features toolbar, and do a manual chain. And select this point here and go to this point here. Escape. I think I hit auto chain. I want to make a manual chain. Go from this point here to that point there. And then I got to tell it I'm done selecting points. So I'm going to hit the stop button here. And so we go to the features view, That was this chain that I just created. You can see that it's highlighted here. I'm going to go ahead and delete the other two chains. So this chain is here. And if we zoom in, you can see there's an arrow on the chain that points from here to here, which is the direction I selected it. And that arrow is important because it tells us the direction the tool's going to go as it does that contour also. And we want to do what we call a climb milling operation. And so when we do a climb milling operation, if we had the edge of the part here, if we're doing the top-down view, and we've got our tool here, the tool is rotating clockwise. And so the rotation of the tool will tend to make it roll along that surface that we want to make. And so this edge of the tool, as it rolls along that surface or as it climbs along that surface, is going to make that surface here. And then the bottom of the tool is going to make this surface down here, right? Okay. So as we do that, so we've got our chain. And you started, I guess you started with one of our templates because you've got all the tools defined here. So we're going to use probably this 3/8 end mill to make that that feature there. Now, all we want to do is select the chain. So I select the chain. I go to my solid mill traditional toolbar. And I don't want to do facing, don't want to do pocketing. I want to do a contour. So I select contouring. And then it lets me, if I go to general here, it lets me first thing you need to do is choose the tool when you're going to do an operation. So I'm going to pick that 3/8 inch end mill. And it wants us to select the feed speed, the feed and speed for the tool. So the speed is either RPM or surface feet per minute. The XY feed rate is how fast it's going to move when it's moving in X and Y. The Z feed rate is how fast it's going to move when it moves in Z. If you don't know what those numbers are, you can go to your web browser, and since you're using one of our tools that we use here at WPI, make a window, go mfelabs.org. Under information for students, there's feeds and speeds. And you're making this out of aluminum, right? Yeah. Okay. So non-ferrous end mills. I've been meaning for about 6 years to change this website because they're not really they're all non-ferrous end mills. None of the end mills that we're talking about here have steel in them, have iron in them. They're all silicon carbide end mills. But these are, when it says non-ferrous, it means end mills that we intend to use to cut non-ferrous materials. And so I'm going to select that one. We have a 3/8 end mill. So I'm going to go down to 3/8 here, and we don't need extra long or anything like that. So just the standard 3/8 end mill that we have here. And if I come over, it tells us, so first it tells us what's the maximum diameter we could have with this tool engaged in the material, which is equal to the diameter of the tool. So that means that the tool can fully slot in the material. It tells us the total length of the tool, this AP1 max. It's how deep can the tool be in the material for each pass, for each cutting pass. And it also, so what's it say? We want to go 0.875, so that's like half of 3/8. No. I don't know, 0.875. That's more than 3/8. Oh, yeah, AP1 max. Sorry, that's the total depth that it can go. AP1 is the depth that we want it to go, which is probably 3/8. It's incremental depth, AP1. There we go. Step over AE in inches. So we tell you that it can fully slot, but when you're using it, you should step over less. But anyway, it says surface speed is 6,000 surface feet per minute. So if I go back to ESPRIT and say 6,000 surface feet per minute, sorry. If you press enter, it thinks you're done with the operation. So let me go back to operations, double click and open it again. So for the 3/8 end mill at 6,000 feet per minute, it wants to spin 61,000 RPM. The spindle in the mini mill doesn't go 61,000 RPM. It goes 6,000 RPM. So let's just change that to 6,000. It'll tell us that it's going to actually achieve 590 surface feet per minute. But we've got that. If we go back to our chart, our depth. So incremental depth 0.375 and step over 0.09375. If we're going to use this chart. So let's go back here to ESPRIT. So, feed rate is next. So feed rate, XY feed rate for this tool says 0.003 inches per tooth. And here it says 0.0006 inches per tooth for Z. So 003, 0006, 1, 2, 3, too many O's, I thought so. I do this all the time. I hit enter when I just want to move from one box to the next. So you just double click and reopen it again. See, this one was not 003, was it? I put in 3, so it wants to go 54,000 inches a minute in the machine tool. That machine can go, I think, 600 inches a minute, so that's faster than the machine can do. Let's make it actually be correct. Oh, I know. Numlock 0.00. Delete all those 0.0003. That's better. 0.0006. There. So 54 inches a minute sideways, 10 inches a minute down, 6,000 RPMs, 3/8 end mill. All right, so we're done with the tool. This strategy here, so we're just cutting on one side of the part, right? So for strategy, we'll do climb milling. I said we want to do climb milling. Number of passes. So over here, you remember it said that we want to step over this 0.09735. So I could take the total distance that it needs to go. That's weird. I could take the total distance it needs to go and divide it by 0.09735 and calculate the number of passes I need to make. But I'm lazy, as all programmers are lazy. So I'm not going to do that. Instead, I'm going to just pick some number that I think is bigger than the number that I need. I don't know, 25. And then I'm going to scroll down here and I'm going to say use stock automation trim. And when I scroll back up, it's going to say process order width. That's fine. Step over distance. So I'm going to do this 0.09375, which I got from the chart, which is 25% of the tool diameter. Stock allowance on the walls. We don't need to stay off the walls. If we wanted stock allowance, if we use a positive number, it would keep the tool away from the surface. If we use a negative number, it would cut the tool into the surface and gouge it. Total depth. I don't know. Do you know how deep that is? 0.375. Okay. If we didn't know that it was 0.375, we could select this selection icon here and go click on the part. And it would put in 0.375. That only works because I did the smash and I created the geometry. So it's got endpoints of lines that I can select there. So 0.375, starting depth is 0. All the rest of this I'm going to go with. And all right, let's say okay. And so what it's going to do now, if we simulate, so I'll single step through the simulation. So the tool's going to come in, it's going to take off that 09375, take off another one, take off another one, till it's done. When it's done like this, and so I think this is the part you're having trouble with mostly, is the next thing we need to do is we need to say, hey, we're done with this operation. And so what I'm going to do now is I'm going to click the save button. So it's going to save the file with all the operations and chains and everything that I created. Then I'm going to click the save button again because I'm not certain that I clicked it the first time. Then I'll typically click it a third time just in case I didn't click it the first 2 times. So now I'm pretty sure that I saved the file. I'm going to go to my simulation toolbar. And I want to do save stock to file. So it's this one here. I want to do save stock to file. And so this is op1 finished, right? But in reality, it's the stock material for op2. So I'm going to call it op2 stock. And save it. So I'll hit escape, get out of the simulation thing, hit stop to get out of simulation. So now I'm here. I got my tool path. I'm going to click save one more time just in case I didn't do it the last 3 times. And then I'm going to do file open. I'm going to make sure merge is selected. And I'm going to find op2 stock. And I'm going to find the op2 stock that I saved today. Where did I save it? Quick access. Documents. Downloads. I don't see op2 stock here. Library. You know what? I don't know where I saved it. I'm going to run the simulation again. I'm going to do save stock to simulation. And I'm going to put it in the downloads folder because then I'll be able to find it. Op2 stock. Save. Now I'm going to hit stop. File open. Op2 stock. I want to make sure merge is selected. And so now I just loaded in the stock that will be the part that you use for the next operation. We already saved it like 4 or 5 times. So I know that I saved the file that can create that. So I'm going to do file, save as. I'm going to call it whatever you called it before, op 2. And so now it's got the stock material, it's got the part, it's in the wrong orientation, right? Because which operation do you want to do next? This one right here that removes this bit? Yeah. So if we do that one next, then we need to have this surface facing up, right? So the first thing I'm going to do before I rotate anything, before I do anything else, we've already made the first operation. I'm going to delete this chain, and it will delete the cutting operation that was associated with it. Basically, I'm going to delete everything I don't need for the next operation. Then I'm going to select everything that's left over. Maybe I'll go to the front view to make sure I get everything. I'm going to select everything that's left over. I'm going to right click and copy. I'm going to rotate. And make sure that it does not say use origin for rotation axis. And I'm going to make sure it says move, not copy. And I'm going to click OK. And it's going to ask me down here to select the center of rotation. I'm going to click that X axis. And I'll go back to my isometric view because it's easier to see what's going on. Was that the direction we wanted to click it, flip it? It wasn't the direction we intended, right? But it'll work. We can cut this one. So we'll do this side next. All right. So we're in this orientation. You want to remove this material here. The part's already exactly the right size, so you don't need to do any facing or contouring around the outside. So to remove this material here, probably what I want to do is I want to make an open pocket. So to do that, I'm going to go to the Create Features toolbar again. And it's so easy to create a manual chain to 4 different points. So I'm going to just hit the manual chain. Select this first endpoint. And so I'm there. Go to this endpoint. I'm there. Go to this endpoint. Go to this one. And go back here. And so now I've made a box that sort of represents that whole thing. In fact, I could have just the box showing if I go to View Masks. And I say, I don't want to see the STL model. That's the thing we loaded in, right? And I can say, I don't want to see the solid model. And so now I see all that geometry. And I see my box. And that's kind of a pain too. So let me turn off geometry. And so now I just see that box. What I'd really like for the tool to do is to be able to go back and forth through this box and not be bounded by this edge here or this edge over here. And so to do that, I'm going to make sure that I have highlight and sub elements turned on. And I'm going to select this chain, and it's going to say, hey, did you mean the chain that you clicked on? I'm going to say, no, I didn't mean that chain. It's going to say, hey, did you mean this element of the chain that you clicked on? And I'm going to say, yes, I meant that. So left click says yes, right click says no. So I want that element of the chain. And we go back to properties, attributes, and say open edge, true. And then just click anywhere it accepts that. When it meets a dashed line like that, it means that it knows that it's a chain that goes all the way around, but that edge is supposed to be open. I'll repeat the process over here. True. And so now it's bounded on this side. It's bounded on this side, but it's open on those 2 edges. We'll select our chain. Go to our solid mill traditional. And we're going to select a pocketing operation. Do you know how wide that part is? It's probably 375. Everything looks sort of the same. I'm going to go ahead and select the 1/4 inch end mill instead of the 375 end mill because it makes this explanation more interesting. So we've selected that 1/4 inch end mill. Oh, 475. All right, so I can pick the 375 end mill, the same one we used before. The nice thing about picking the same one we used before is we remember what the feed speed and depth of cut are probably, right? If not, we still have that tab open. But so general, we want to do a roughing pass. I'm going to say no to the floor finish and the wall finish pass. What saying yes lets you do is it lets you pick, actually, I think it lets you pick a different tool and a feed speed depth of cut. But hey, this is not my project, it's your project. So I'm going to say no so I only have to program one thing. And I suggest that you guys only say no or only do one thing also. Unless you find out when you make it that you don't get the surface finish that you want, and then you could adjust those things. But it's a pretty simple part here. So I'm going to say just do the roughing pass. Strategy. So we can do, there's all kinds of choices here. It's beyond the scope of this explanation to go into all the different choices. But I like concentric out because it seems to me it starts in the middle and it moves towards the edges. And I feel like that's good. So I'm going to use concentric out. This morph move you can set to yes or no. Spiral you can set to yes or no for this operation. Doesn't really matter. So full engage % of feed rate. This one's actually important. So when the tool is fully engaged, that means it's in the material and you're wrapped all the way around it. So it's not like making passes on the side. When it's fully engaged, it has more force on it. It's loaded more heavily. And often the tool manufacturer will tell us to slow down when it's fully engaged. And they'll call it slotting. And so for slotting, it's somewhere, no, when slotting with the full diameter of the tools engaged, reduce X, Y, and Z feed rate by 20%. So go back to ESPRIT. Where'd it go? Oh, here it is. Fully engaged. So percent of the tool. So this is asking how much of the tool needs to be engaged for us to consider that fully engaged. We're going to go ahead and say 100% needs to be engaged. But then down here, fully engaged percent of feed rate. So it says subtract 20%. So we'll do 80%. Which means for that instant when it's fully engaged, it'll slow the tool down. And then when it's only side cutting, it will speed the tool back up to what we programmed. Here we go. Once we put that number in, 80%. And we'll just stick with 100% of the radius has to be engaged. So that's 180 degrees of the tool is touching material. Then it's fully engaged. Total depth. What's the total depth we need to cut to? Do you remember? I don't remember either. So let me turn the geometry back on. And if I rotate it a little bit, I can see where that shelf is. So I'll go ahead and select total depth. I want to go to, now I'm all confused. It's like one of those Escher drawings, right? I want to go to that point for my depth. Total depth, incremental depth, starting depth. What was our incremental depth for this tool? Incremental depth is 0.375. Starting depth 0. I'm going to say stock automation, yes, again. We probably don't need it for this operation. Toolpath, stay inside feature. I'm going to just leave that alone. All right, pocket. Are there any islands in your pocket? Any bits of material you want to leave in the middle? The answer is no. I've seen the part, but if there was something sticking up in the middle and you wanted to tell ESPRIT, don't cut that, that's where you'd click here and then you'd go select something over there. Read taper from feature is fine because there is no taper. Open edge offset. So how far past the part do you want it to start and stop? So I usually use this 110%. Rough, here's where we do our speed. Do you remember what the speed was? It's 6,000 RPM. It was 0.003 and 0.0006. We'll climb, we'll step over 25%. Entry mode, because we're doing an open pocketing operation, we actually don't care what the entry mode says because it's going to come down outside the part and feed into the part. But if it was a regular pocketing operation, we would either want to use ramp along pass or ramp contained. We would want the tool to always be moving sideways when it's feeding down, never just feeding down. But we don't really care because it's an open pocket. Links. This is really mostly important if you have multiple operations in a row that use the same tool. Since this program is only going to have one operation, we don't care what that says either. I'll click OK. ESPRIT could not find the area of the part to cut. Verify stock definition. Okay. So the problem is we loaded the stock file in, right? We've got it there. It's our STL model. That's our stock. We never told ESPRIT that was the stock. So before we can have this operation, we have to actually go to the simulations bar, go to the simulation parameters, tell it the stock, and delete this one, the stock from solid. Select the feature, select the solid, add. Okay. Now, go to our operation, our pocketing operation. Select the chain. Go to our pocketing operation. If we're in luck, it remembers all the things that we put in. Let's just double check. Nope, didn't remember anything. So 3/8 inch tool. Cut speed. Oh, it's a contour cancel. Pick the wrong one. Select the chain and create a pocket. And 3/8 end mill. Concentric out. None of that stuff matters. 80%. Total depth, I forget. Click there. Starting depth 0. Stock automation. Trim. Stay inside feature, sure. Pocket. Nothing special on the pocket. Rough. 6,000 RPM. 0.003. 0.0006. 25%. I don't care what this stuff is. Links, I don't care. Okay. And now we can simulate. And so now we've got two features on our part. Save, save, save. I'm a proponent of saving frequently. Save the stock material to file. Op 3 stock. And it's in downloads. Okay, save. Yeah, sure. And file, save as. Op 3. Save. Hit stop. All right, so we want to delete this for Op 3. Delete this stock for Op 3. File, open, merge, Op 3 stock. We've got that here. I'm going to remember to go ahead and set that as the stock now. So I'll go to simulation parameters, delete the old stock, new stock from solid. That's the one, add, okay. Turn on my solid. And I'm going to do edit, select all. Copy, rotate, move, 90, okay. And put it in the right operation. And then just repeat those same, right? You're going to create this open chain the same way we did the last one. And you're going to have that same operation to remove this material in here. So actually, because you want to make the same operation, let's go ahead and make the chain first. So my manual chain, I'm going to do this one. Nope. Endpoint. Manual chain. This point, this point, this point, this point, and my endpoint. I want those two edges to be open. So select the chain, say nope. Yes, I want that one. And then I'm going to hold down control. I'm going to hold down control. I'm going to select the chain. I'm going to say nope. I'm going to say yes, that one. And so I've got both of those selected. I can do attribute open edge true. And that makes both of those edges open. I'm going to do file, save. Then I'm going to go file, and I'm going to reopen the last one we did, op 2, right? I'm going to open up op 2. I'm going to go to my operation. I'm going to right-click, file, save process. I'm just going to call it temp, save. I'm going to go back to the one I'm working on, op 3. I'm going to select the chain, right-click, file, open. Temp is the one I just saved. And so it copied all the parameters we set for the last one. We can simulate and see that it makes that cut too deep, right? So all we do is go back to the operation, hit stop to get out of simulation, go back to the operation, find the depth part in strategy, total depth, and select that height instead. And so then it makes the feature like that. And then click save, 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 and then we're done. So then we've programmed that part. It all used the one tool, take the stock material, flip it over, flip it over, flip it over. Was that good? Has anybody else emailed me a file to look at?
I did. I'm all set.
Well, I'm not going to look at your file. That was the last time, right? Or Hayden fixed it?
Yeah.
Anybody else email me a file to look at? You can ask, but I didn't hear you, so let me walk over here.
Like it's working now and stuff, but like how come initially it like was changing the axis that the chain I was in was like that sounds so weird.
No, I know. So yeah, because we talked about this last week, and you were having some trouble making the chains so that they were in the orientation you wanted them to be. Yeah. So let me. I'm going to go back to op 2. So if I'm here at op 2, and I've got the op 2 program done, and I want to make the op 3 program. What we do a lot of times is instead of selecting everything and doing copy rotate, a lot of times what we'll do is we'll just so I'm in the isometric view right here. If I just manually rotate it around like this, and let's say I wanted to do a facing operation on this side. We don't need to for your part, but let's say we want to do a facing operation right here. So it'd be pretty easy to select this face, highlight sub-elements, maybe. Turn the solid back on and turn the STL off. There we go. So it would be pretty easy to select like a face like this. If I remember what I'm doing. So I want that face there. Let's say I want to do a facing operation. I can go to auto chains. And let's say we'll go to auto chain. We'll do a we'll just make a chain that goes around it. So I've got my manual chain here from this corner to this corner to that corner, over to here, over to here, and over to here. All right, so we've made a chain that went around the part. We've got the part facing in the orientation that looks good to us. We select that chain and we say, let's make a facing operation. And let's use the face mill. I'm not going to bother to look up the feed speed depth of cut here. I'll just leave them zeros for now. But if I click OK, it's going to say inappropriate features were selected for input. Sometimes it says, if you're doing a turned part, if it's in the lathe, it's going to say need another axis of rotation. But when I see that message, the first thing I always do is go here and click isometric. And then I realize that although I rotated my view of the part, I didn't actually rotate the part. So the plane that I drew in is not facing the direction the tool can reach. And so I think that's what you were seeing when you were trying to do it before. You were rotating your view, but not rotating the part. That's my guess. Without watching you do it, that's my guess as to what was wrong. So that's what's that common newbie mistake? And the reason I can so quickly recognize said newbie mistakes is because I've made all of them. Anybody else has sent a file that want to go over something that they looked at? Anybody have a specific question then of something they want to go through?
We look at like mill turn setup, so I know we know.
Mill turn setup in ESPRIT or mill turn setup on the machine? In this, okay. Can you send me the file you want to turn? And yeah, and give me like a 3-minute pause because I've been up since 20 to 4 this morning, and this is not my first cup of coffee. But I will. The microphone here.
Oh, well, too late. I should have left. Well, what's the transmission? It's definitely supposed to stop the thing, but yeah, it definitely isn't shit. Dude, that thing's 30 years. It's aggressive. I'm not kidding. Well, the two are done now. I had to make.
All right. You had a mill turn question.
Yes.
Let me remic. All right, I'm remiked. Let me see if it's actually mic'd. Settings. Audio. Yep, it's actually mic'd. Sorry to the people at home for all that banging noise you just heard on my mic. You emailed it to me?
Yes.
All right, let me not screen share my email. And this is like the coolest feature of projectors. Freeze. Mail. Close. ESP. What did you email me? Oh, no, I found it. The one that says file not contouring properly? No.
No, it says no. Oh, that's.
Who'd you email it to? Is it an ESPRIT file?
Oh, no, it's a solid word, but that's what she said.
Oh, well, then I won't be able to find it by searching for .esp.
Yeah.
That explains a lot. Got it. And all right. ESPRIT. All right, now I can unfreeze. Unfreeze. And reshare. All right, file open. I don't care. Cancel. File open. This is the one?
Yep.
Screw 62. So I have a funny story about your file name.
What's that?
So back in the early days of the internet, I worked in the surface metrology lab, which was upstairs in this building. And we transferred a lot of data sets with a lot of data points in them. And there was a BME student, Melissa, who came to work in the lab to do some research. She was measuring. They were looking at bone screws. They were looking at the surface texture on bone screws to study bony ingrowth. So they would have bone screws with different textures, and then they would see how the bones grow into them. And I don't know how the BME research side of it worked, but I do know that we were measuring bone screws. And she named her files Melissa Screw 1 and Melissa, because yours is like Screw 62 here. And we did these data backups every day. And people had to check to see what we were posting on the internets back in the day. Before that was like the normal thing the internet was used for. But it was, turns out it was 3-dimensional measurements of bone screws. But when I saw your file name, I had to chuckle. All right. So let's see. Because I merged it into my existing file. I don't want to do that. I'm going to do file open again because I don't really want to cut your what. So is it really an impeller?
It's a screw.
I mean, I heard you guys refer to it as a screw. If I would have thought it was like an impeller. The purpose is to compress air, right?
Yeah.
I guess it's like a screw compressor kind of a screw. Yeah.
Is it an impeller?
No, I guess an impeller I think is different.
Is it the opposite of a turbine?
Yeah. It might
From the center.
the screw in a screw compressor might actually be an impeller. I don't know. Like if it was a pump, if it was pumping water or something, I would call it impeller. And I've seen plenty of pump impellers that had that shape. With like rotary pumps. So yeah, but when we're compressing air, we call it a screw. That's right, because same thing like a rotary screw compressor.
Yeah.
for air, which there's one right on the other side of that wall. Yeah, but we're not going to cut it out of that piece of stock material, right?
No.
No, okay. So I'm going to just go ahead and file new. No, I don't want to save any changes. I'll create a blank document. I typically don't like to start with a blank document because it doesn't know anything, right? So we have to set up a lot of things. But I think for the sake of the tutorial here in the class, it makes sense to go through setting up some of those things too. So now file open, downloads, quick access, downloads, screw 62, and isometric. Okay. So the first thing we want to do is orient it such that the lathe could touch it. And so I'm going to select it, copy, rotate 90 degrees. Okay. And use this axis. Yeah, it doesn't seem correct. Control Z. I'm going to stick with my 90. But because I'm going to show you how to correct when you did the wrong 90. You could also do negative 90, which would be 270. But I never remember which direction to go. And it's not that important to me as a person to have remembered that. Because when I say 90, okay, select this axis. Oh shit, that's not the direction I wanted to point it. I can either undo and then go to negative 90, or I can just right click, copy 180, and that's going to work. Conveniently for us, the jerk designer at least had the center lined up with 0. But if not, we could figure out what that center point was, and we could shift it around, and we could get it lined up so it's on the axis. So we've got this. I'm going to go back to isometric, because when I go to isometric, it gives me some perception. Is it actually pointed the direction I think it is? And so in the lathe, with my fancy video work here. In the lathe, the spindle is over here, and it's going to hold on to the stock. In the stock, if you're doing a turning operation in the lathe, the stock's going to rotate like this. So this is the Z-axis of the lathe. So that this axis right here aligns with the spindle in the lathe when we're in the isometric view. And so that's important to know how to line it up. So we're lined up like that. And what we want to do is first we need to tell ESPRIT that we're doing a turning operation or a mill turn operation, right? So switch to solid turn. So when we first open up, and not everybody when they open up gets this toolbar in the same place, so I'll pull it out here. It's the smart toolbar. And I like to keep the smart toolbar on the second row of toolbars all the way to the left. And it's when I set up where my toolbars are, I always put it at this location. Well, except for this instance, right? I'm not sure exactly what it is, but I have had some trouble aligning toolbars with the computers at WPI. And I think it's because we don't actually have the video driver for the monitor installed. I think we just have some generic video driver installed. That's what I think the problem is. But that way I can blame the IT guys.
Yeah.
Right? So, because if you can't blame the IT guys, you have to blame the software developer. And they've been really generous with us. They give us, I mean, when they gave us the software in 2005, the book value was like $3.5 million of what they gave us. And they update the license every year at no cost with the full suite of things. And so it's like $35,000 a seat or something like that. So they're generous to us. So I try to blame our IT before I blame the software developers. And in my defense, hey, IT won't return my phone calls, so it must be their fault. But hey, if you guys are monitoring the stream, I didn't actually say that. I get hacked. It was hijacked. All right, so we're here. What we want to do is hit this solid turn. It tells ESPRIT that we're going to make a turned part instead of a milled part. And then when we go to our machine settings, our common machine settings, which is this one, common machining, on the toolbar, we can also go to machining, common machining. Now we're going to go to machine setup. So with a lathe part, you need to do this. You don't actually have to say what the machine name is, but it's nice. So we're going to use the ST30 SSY. I'm going to leave all that stuff alone for now. Assembly and NC output. So the first thing I want to do here is I want to give it a program name. Screw 62. Just so when I create the code, it has a program name. And I'm going to give it a program number so that it's not 0. That's too many digits. That looks pretty good. Sometimes I try to use sequential program numbers if I know I'm going to do that. Sometimes like ME1800 programs, I'll start with 1800. But it just needs to be a 5-digit number. If I go back to general, this is actually what I wanted to change. So the bar, so it's going to come out of a bar. You could make stuff out of a tube or a casting. If you have a casting, then you need to have a solid model that defines what the casting looks like. We're going to cut it out of a bar because it's solid. What's the maximum diameter? 4 inches. We'll go ahead and change that to 4 inches too. And we can change the total bar length, but that's just really going to show up here. So 12 inches is long enough. If we need to do some of that stuff for the simulation, we can. Now you'll notice that your part sticks out from the stock material when I did that. So what I usually do to fix that, isometric, except I can't see the part that sticks out in isometric view, right? What I'll usually do is select the stock, copy. I'm going to move it. I'm going to translate, move X, Y, Z. Now, in the lathe, this lines up with the Z-axis, right? Yeah, but when we're viewing it in ESPRIT, it's still the X-axis for us. That's in the manual, so it's a feature, not a bug. So we're going to move it in X, negative, I don't know. How much is that little nib that sticks out? Ish. So let's move it 0.75. Negative point, I don't know if I did the decimal place. I did, okay. What do you mean incomplete? Oh, because I didn't tell it 0 in Z. Ah, your shaft is not attached to your other piece. Yeah, well, you didn't design it that way. But that's okay. We can select this one and do the same thing. There, now we moved the whole thing. I actually knew that because I've looked at your part before. But I had forgotten until I saw it happen. All right, but now like the finished part is actually inside the workpiece material. That's a good thing, right? All right, so I think what I would do first in this situation would, well, so we're holding it. The chuck is over here. We want to have plenty to hold on to when we do our other operations. I would do a turning operation first to get it close to like the right part profile. What's up?
Are the green shapes, are those not representing the chucks? What are those representing?
Oh yeah, that represents the chuck in the simulation. You want to fix that?
I don't know how to say yeah.
Yeah. Yeah, I usually ignore that because it doesn't represent the chuck in the machine tool. It represents the chuck in the simulation.
Okay.
And I usually ignore that right up until I click play on the simulation and it crashes, and then I fix it. But yeah, we can fix that now. It's back here in machine settings. And we want to go to assembly. And I think we want to look at main spindle. So this -6 for the home position, that's telling us to put the chuck 6 inches. Where are we? Assembly main spindle is -6 here. Is telling us to put the chuck 6 inches from 0 over here. And we would like to hang the stock material further out of the spindle. So what we can do is we can make it more negative-y.
Is that like the front face of the chuck that it's measuring from?
I don't know. Could be the front face of the chuck that it's measuring from. I don't know. I've never, and that's, so 12 was plenty. 12 makes it so that it's totally not going to crash in the simulation, like crash into the chuck, right? And that's all we really need for this phase of it. It won't impact the operation in the machine tool. It's only going to impact what we visualize in the simulation. And so if we actually talk about simulation here, also there's another thing to set up. So if I click play on simulation now, it's just there's no tool paths. It's just going to draw the stock material and the turret. And so there's our chuck. Didn't even draw a turret. Oh, I have turret turned off up here. Stock visibility, fixture visibility, table spindle visibility, head turret visibility. There we go. Yeah, so that's going to hurt when it does that, right? But it's not actually what the machine looks like. So if we wanted to, we could measure where the turret is exactly in the machine, and we could get it to simulate exactly perfectly. And certainly if I was selling the software and I wanted to demonstrate to you that the software represents your machine, I would totally do that. If I wanted to prove to my boss that it was okay to run the program in the $150,000 machine tool, I would probably do that also. But if I wanted to prove it to myself and I believed, I would just make it look like it doesn't crash in the machine, in the simulation, right? And that's my lazy ass excuse for not going to the machine and measuring all the stuff right now. But what I can do is go back to that, simulate the settings, common machine settings, go back to assembly, index turret. For one thing, I don't think it even has the right number of tool blocks on it. And off the top of my head, I don't remember what the right number is, but you can add stations somewhere here, new station. And so, yeah, so it only shows 7 stations, but that turret definitely has more than 7 stations. So you can add more stations. Maybe it has 12. I don't remember. The problem is it doesn't know where to space those stations when you add them like that. So what you can do then is there's a button. I haven't done this for a long time. I actually haven't done this since I created the templates that I would prefer to use when we start this. But tool rotation angle, there's a way to have it automatically put the stations at the right place. Maybe I click OK here. Oh, not OK. Maybe I go back to index turret. So it's not under new, configure stations. Pretty sure when you click that button, it just distributes them evenly around the turret. We can click ensure tool number matches station number. That's pretty good. It makes it harder to screw up. But we got 12 stations on there. So what we really wanted to do, though, is fix the home position for the turret. So it needs a positive X value. And X is this way in the lathe. It's in and out away from you. I think that number is in the range of like 20 inches, maybe a little bit less than that, but I'm going to pick 20. And it needs a positive Z value. That's less than 20 because we're looking at the center point of the turret relative to the center point of the spindle. So I'm going to guess 20 inches maybe because it's a ginormous turret.
So,
but for the Z value, I don't know, 15.
So those XYZ coordinates
are the so if I
XYZ.
It's what, yeah, because we're setting up the simulation.
Yeah.
We're setting up what it's going to look like. So if I hit play to simulate now, and I go back to isometric because that's totally upside down. There we go. That's sort of what we see when we look inside the lathe, right? Yeah. The turret is away from us and over when it's at its home position.
Yep.
So you can, in the lathe, well, I'm sure we could Google it. We could look up what the actual numbers are. But when it's at its home position, what we want there is the location of the center of the spindle, or the center of the spindle at the chuck to the center of the turret over here. It may be measured from 0 in ESPRIT, not from, you may have to subtract that -6 or -12 that we put in.
Yeah, but when you enter a Z value in that menu, it shifts it.
It shifts it the correct way, not the ESPRIT way. Yeah, it shifts it the way it is in the machine, not the way it is. There's a way to make. There's a way to have the XYZ be correct, but I never bother. I know there's a way. I've never bothered to learn what it is. I just remember. Hey, James. Hey, this is perfect timing. Step over here because we've gotten to the point of the mill turn training where I have told them how to set up the machine, put their stock in, and set the turret where it needs to be. But they need some help with their part. And I was going to look at their part and figure it out before they asked that question again, but I didn't. I've got it here. You can come over here and help. Hit stop on simulation. That's their part. Wow. Hey, for everybody that doesn't know, this is James. James is a quitter, but he's on vacation today, his other job.
Yeah.
It's perfect. I want to just rotate the C axis and do some contours there with a ball end mill. That's what I want to do.
Yeah.
I can't remember the ESPRIT toolpath that does that.
Oh, and you need those little icons changed too.
What little
Remember the
icons?
trick to do that? How to get the bigger icons?
No. Show us how to get the bigger icons.
Can we save it and close it? Do you have to save somewhere?
No, just save it. Screw 62. I don't know why it's 62. Was that like the 60-second try you guys made to design it?
That was the name of the file. Yeah.
Oh, it's the 60-second try somebody else made to design it.
Yeah.
It was like WD-40, right? It was like the 40th attempt. Yeah.
So under compatibility in properties, change high WPI settings, override scaling performance behavior, and then system, and then okay. Yeah, system. Fine.
That's perfect. Perfect. We'll just split that out as a separate video now.
Yeah. I have
Because I knew there was a way.
I put it up-
There was people here that had that problem, and I said, hey, there's a way to do that, but I don't know what it is. James does. Oh, yeah. Now we can see the icons. All right. So we need to make a tool because we don't have any tools. But let's go ahead and make a tool. This I know how to do. Go to tools. Let's put it here. New, milling tools, ball end mill. What diameter end mill do you guys want to use?
You said the max.
I did say the max you should use is 3/8. That's what I said the max was. You don't have to go to the max. Point 0.25.
Were you doing this in the SDK?
Ball mill, yeah. Over here we say 0.25. And here, this one's important. We need the tool to point the right direction. So it could line up with the z-axis, or it could line up with the x-axis. For this tool, we'd like to rotate the part and have the tool move like this, right? So we want the tool to point at the, I think it's positive x. I think this is the one we want. And when we create it like that, it shows up out here. Let's move it to the station number 1. Now when we hit simulate, ooh, that was pretty long. We're probably not going to use a tool that's that long.
Yeah.
Oh, that's what you were here for?
Yeah, drop those off.
Key return. We'll leave them there for a few weeks.
They turn my email off, but then it's back on.
Yeah, because you're an alum. You get emails. No, but I'm serious. I want to know how to program this toolpath now.
Oh, I think I'm doing wrap contouring.
That's what I thought too. So how do we make the feature?
It's gonna be a chain along one of the.
All right, so we want to make a chain along one of these edges, like the top surface edge.
Yeah, I probably would. The only thing that's gonna be weird about that one though is it's where it's a surface though. You may not be able to get away with.
Don't we have to make the drive chain thing?
Yeah, you probably will.
That
In a
sucks.
different. So it may not end up being the wrap contouring that'll let you do it. It might.
Is it wrap pocketing maybe?
Yeah. Probably want to.
So I think we got to make a chain all. Like, do we want to do all the way around or just do one and then rotate?
Yeah, I'd probably end up doing one and then rotating around.
Me too. So one goes from this edge. All right, so let's make a chain. Are you just here to drop off keys or are you going to stick around for a while?
The family's actually in the car. So we gotta go pick up groceries too.
They said you were going to be here today. They didn't say we're going to pass through today. Like you lift me up to this high, and then you just let me fall. Right? Just lift me up to this high, and then you let me fall. Anybody else watch the Daytona 500 last night?
Barely.
So I watched it because, well, I guess I'm a Stuart Haas racing fan because of the Haas connection, right? But so Tony Stewart is in the booth. He's like one of the announcers on Fox. He also owns one of the race teams. And in like the last, I don't know, 15, 20 laps, 3 of his cars were in the top 10, and one of them crashed. And you can hear in the background as like the crash is happening, you can hear, "Dang it!" He must have felt like that, right? It's like, I got 3 of my 4 cars in the top 10 at the Daytona 500 in the last laps, right? He must have been like rising up, and he's trying to be calm because he's like the TV guy. Right? Yeah, and so here's James. James walks in. I'm like, oh, James is coming. James knows how to do this. He could figure this one out. And then all he does is give me keys and leave.
Yeah, I'll take him back. Ian said that there's a letter for me in the office?
See? I don't even get to keep the keys. I was up here. I was like, I'm going to win the Daytona 500. Dang it. All right. You learn to say things like "dang it" in Indiana and Kentucky. I personally learned it in Kentucky. I'm pretty sure Tony learned it in Indiana. All right. So what James and I think we need to do is a wrap contouring or wrap pocketing operation. It's because it's got the 2 twists. If it was straight, a wrap contour would do it. We could make a chain that defines it and run that across. And it's been 10 years since I've done one of these, but I figured it out that time. So what I think we should do first is go to this solid mill turn freeform. Not that one. Solid turn wrap, legacy wrap pocketing, legacy wrap contouring. I think because of the double twist, we have to do a pocket. I don't remember how to do that. So I'm going to click on it anyway. Oh, yeah, screw you. I got to pick something. I don't think that'll work, but sure. Yeah, incompatible. Let's create some features then. Create features, freeform feature, part. Oh, let's make that surface. Let's make that surface. Let's make that surface. That sounds cool, right? No idea if this is going to work, but let's try it. We definitely want to wrap. We want the C axis to operate, and we want the tool to move in the X or in the Z direction while the C axis operates. That's what we want to do. Okay. So now features. Now I've got this freeform feature. I don't think it works with the legacy thing though. Yeah, incompatible. Because that legacy wrap pocketing, it wants us to have a chain that drives the feature along there. I'm sure that if we go out to the solid mill turn one, Oh, 3D contouring operation, concentric finishing. I don't know. 3D contouring operation. That sounds cool. So I've never done this one before. I never clicked this button before. It's got to have a chance though, right? Well, hey, it accepted our feature. We're going to use that tool. Before you run it in the machine, you're going to have to know things like feed speed, depth of cut. but I just want to know if it makes a toolpath that's sort of the shape I want before I bother to worry about those things. Toolpath profiles. So I'm thinking that we can define a chain that tells it what direction to move the tool. And so we may need to do that before this will work right. But here's what I really wanted to do. I really wanted to open up one of these features or one of these operations so that we could click on the context sensitive help. The thing is, who's ever read like the help thing for software before? Who thinks that software help files suck? Yeah, the ESPRIT guys never got that memo. Like, I have learned how to do so much stuff in ESPRIT simply by opening up the operation and clicking the help thing. And then it actually brings you to, like, hey, 3D contouring. Well, that's cool. And so setup and all these things, like, wait, here's general tab. So it tells you all the things on the general tab and what they mean. Here's the toolpath tab. So it tells you about these things here in the toolpath tab. Oh, that looks pretty cool. I do think we're going to need some kind of a chain to tell it to drive along the surface there. But it's getting us in the right direction. So it tells you what all the different things mean. But reading is way overrated. I'm just going to click OK and see what happens. Invalid profile. Yeah, because we didn't pick a profile. So we got to make a profile before we can do this. So cancel. I'm going to hit your part here, copy, right click. Do I want to do that? Smash. Sure. Did that make... Now I want to have highlight turned on. Yeah, so that made a line. Sometimes when you do the smash, it makes a bunch of line segments. That isn't what I wanted. I wanted to make a nice solid arc. So at least it interpreted that as a nice solid arc. So I got that selected. I'm going to create a auto chain on that. And so now it made a chain on that profile I liked. I'm going to do the same thing for this one. And auto chain. We may need to make a chain that goes like encloses that whole thing. Actually, if we do that, the wrap pocketing thing might also work. So we can do that after we're done with this try. But I've got those two chains. I got my freeform. I hit my freeform. Go back over here to, which one was I trying? This one, 3D contouring operation. Profile. Yeah. Yeah. Well, hey, that did something. It doesn't look like it did anything good, but it did something.
Yeah.
Oh, it did something. And it crashed going between the two chains. But that's a start, right? So hit stop. Maybe we didn't, maybe we need to give it depth or something. Like, we didn't look at most of the options. Two bath general. I said read the help, but let's just try. All right, so cancel. I'm gonna go ahead and delete that. We didn't invest too much time in that one. Let's make a chain that defines one of these pockety things, right? So we're going to do an auto chain. Now remember, I already did the smash, so I have geometry that shows all the outlines of the feature here. You can't do this unless you already did the smash. I'm going to start at this spot right here. So I'm connected to that endpoint. And it's asking, choose next element. So what it wants to know is, like, what's the next line segment you want this to follow? If you find the middle of a line segment and like you see the endpoint thing and you happen to click at that moment, it's going to tell you, I didn't ask for a point, I asked for a line segment. It's going to fail. But if I click anywhere on that line segment that's not there, it's going to say, hey, did you mean this one? I'm going to say yes. And so now it's saying pick the ending element. Well, I could pick the start point again, and it might ask me what path do you want to take around the part that's connected by lines. And if it was a simple geometry, I probably would do that, but there's too many options for it to pick from here. So instead, I'm going to come up to this point. I just wanted to follow that contour up to this point and say, yep, I want to be, oh, come on, don't say that. All right, so I'll pick this endpoint. And it's picked that one. Now it's saying choose next element. I'm going to pick this one and this endpoint. So I'm going to do it manually for all of them. And I want to go to the other end now. Oh, no, no. Choose next element. I want it to be the line. Then to the end. This element to that point. This element to that point. This element to that point. And this element to that point. So now it made a chain. If we turn off, go to view, masks, turn off the solid, turn off the lathe stock, turn off the geometry. Sometimes you need geometry for stuff, but it's a pain when it's in the way and you can't see what's going on. And let's turn off that other toolpath. I thought I deleted it. It must be the freeform feature it's showing us. Anyway. So that's a chain that defines the edge of what we want it to do. I think, let's try that chain now. Let's do our freeform feature. Oh, but I didn't define the chain on the same spot as the feature, right? Let's delete that freeform feature. Let's delete that chain. I'm just deleting this stuff. Oh, that's all geometry or something? I don't know what it is. I'm just deleting stuff I don't want to look at. All right, so now we just have that one chain and whatever this is. Now we just have that one chain that we can see. Turn back on the solid. So our solid is now under the chain. Let's create a freeform feature that's in between that chain. Create features, freeform feature, part, this. Okay, so now we've got that freeform feature and we've got a chain that bounds it. Now let's go over here, try that 3D contouring operation. Select the freeform, try our 3D contouring operation. And cancel. Did I? Freeform feature. Profiles. That's different from what I did before. Still not quite what we wanted. Huh. We should probably take a little time to read the help. But sometimes just trying it is fun. I select this one and I go back over here to my legacy wrap pocketing. I may have to give it some depth. Let's, no. See, but I think the problem there is that it didn't like the plane that the chain was on, or the side that it was cutting on. It was trying to put the tip of the tool just outside this edge of the chain. So I'm going to look at my definition here under machining. It's trying to cut, yeah, it's not trying to cut the thing I wanted it to cut. So machining cut side center. So it doesn't see the chain the way I intended for it to see the chain, right? Oh, but it does open up. So I can get here and I can click help. Now I could have just opened up the help and searched for it. But I really like the context sensitive help. So legacy wrap pocketing. Let's see what they tell us how to do this, right? So they made a chain that went around something. So introduction to legacy wrap pocketing. All right. This stuff is what we think it is, strategy. OD. Escape. Go back over here. Move this up here. Strategy. All right, general. Wrap pocketing. Yep. Let's try. So it's going to be one of those. And what I would do is go through and read the help
Yeah.
and check those things. You're going to want to make sure your tool's pointed in the right direction. Those are the things that'll come up, is whether the tool's pointed in the right direction. And I've got if I dig for it, I'll find a PDF that I can send you. If you email me, you emailed me the file, right? So I can reply to the email with the file. And I can send you a PDF that shows how to set this operation up.
Yeah.
It's just that it was 10 years ago the last time I did it, and it took me like a week to figure it out the first time. It could take me a week to figure it out this time too. But hey, James's email's turned back on. James could figure it out quicker than a week.
Okay.
Because for the whole time James worked here, when one of these things had to get done, I just said, hey, James, you do it. And that works right up until all of the staff quits. Or
salty almost.
no, but he just gave me the keys. I thought he was like coming to visit. Left his family in the car. He should have brought his family in to see us, right?
A lot of sharp stuff out there, though. I know he's got like little kids.
No, when my kids were younger than his, they used to run around and play in here. They would run around, and like my daughter, when she was really little, she would walk around our machine shop and she would pick stuff up and say, Daddy, I found some sharp stuff, like chips and fasteners and whatnot. Daddy, I found this sharp stuff. There used to be a greenhouse in our backyard that when they took the greenhouse down, they decided to break all the glass. Before I owned the house. But the lawn now just grows broken glass. And she's like, she just picks it up and piles it up. She's older now, but even when she was little, she used to just find broken glass and just put it in a pile. So,
One question. Well,
do you want your question on camera, or do you want to have it? Okay.
do you have like the secret professor stash of tool holders for the ST30?
There's no secret professor stash of tool holders for the ST30.
All right.
They're all available for anyone to steal.
So if there was like more than the ones that are currently in the machine.
Oh, well, there's more than the ones that are currently in the machine, yes.
Okay.
But it's not like a secret professor stash.
Yeah.
It's in the drawer next to the machine.
Nope,
That's where they're supposed to be.
they're not.
Well, I know where the brand new ones are that are the same as the ones that
So
go in that
they-
turret. But they're not secret. I just happen to know where they are. Let me turn this off.
Us.
They're not secret.
Well,
Let me go ahead and turn this off.
We were looking for them and we couldn't find them because they're different shape than the ones that go in the one or the 15s or whatever the models are.
We have two different types. Let me go ahead and stop this screen share thing and broadcast.